Alright, here's another tutorial to help you out with graphing these parabolas in standard form, which again is our y equals ax squared plus bx plus c. So the first step when I'm graphing a parabola is I want to figure out what's my vertex. So the vertex is always negative b over 2a for my x-coordinate when we're talking about standard form. And then for the y-coordinate, I need to plug negative b over 2a back into my function to figure out what's the appropriate y value that matches up with that x value. So that's why standard form again is a little trickier than the vertex form when we're graphing, because we have to do some work to figure out where that vertex is. So if I look at A, here I have 1/3 is my A, and if I look at B, here I have 2 is my B. So let's do negative B all over 2 times 1/3. And let's do this bottom part first. So I have 2 times 1/3 on the bottom, and that is going to become 2/3, right? Because I had 1/3, but I multiplied them by 2, so now I have 2/3. And then if I do negative 2 divided by 2/3, well, remember that dividing by a fraction is the same as multiplying by the reciprocal of that fraction. So this is the same thing as if I write negative 2 times 3/2. And now these 2's are going to cancel out, and I'm just left with negative 3 as my x-coordinate. Another way I could have done this, actually probably would have been faster, is I could have noticed at the beginning, when I'm here, I can cancel out these 2's, and then I'd be left with negative 1 over 1/3. And when I have, again, this fraction on the bottom, it becomes the reciprocal, because it's like negative 1 divided by 1/3. That's the same thing as negative 1 times 3 over 1. And either way I do it, I'm going to get back to 3. So in any case, the x-coordinate of my vertex is 3. Negative 3, sorry. And now let's plug negative 3 back into my equation to figure out what the y-coordinate is. So I'm going to have y equals 1/3 times negative 3 squared plus 2 times negative 3 plus 5. Negative 3 squared is positive 9. Negative 3 times positive 2 is going to give me negative 6, and then all plus 5. And now I do 9 divided by 3 is 3, minus 6 plus 5. So this first part gives me negative 3, and then plus 5, and I get positive 2. So my vertex is negative 3 comma positive 2. So let's put that point on our graph right there. Now I'm going to make more space for myself to work so that we can plug in a couple extra points and figure out what this parabola looks like. And remember, it's going to be symmetrical across the axis of symmetry, which is going to be this line, x equals negative 3. It's going to cut my parabola down the middle. So I only need to figure out what 1/2 looks like, and I'll get the other half for free. So the bad part about graphing in standard form was you had to do that work to find the vertex. The good part about graphing in standard form is there's one point that's always really easy to find, and that is what happens if I plug in x equals 0. Well, then all this 1/3 x squared plus 2x business, right? This whole thing is just automatically going to be 0 because I'm multiplying by 0 for both of those terms. So I'm just going to get 5 for my y coordinate there. So standard form does have its perks because it's super easy to find the y-intercept there. So when x is 0, y is 5. And remember, again, graphing in standard form, you get to figure out what points you want to plug in for x to get your y points. So let's pick some points that make it easy for us. I can choose the x points, but then once I've made my choices, I need to make sure I'm doing the right thing to solve for y. So let's just choose x equals 1 because that's going to make my math easy. So I'm just going to have 1/3 times 1 squared is 1 plus 2 times 1 plus 5. So I have 1/3 plus 2 plus 5, which is going to be 7 and 1/3. So not the prettiest point, but we can still put it on our graph. So that's going to be right about here, 7 and 1/3. And so this side of the parabola is going to look like that. Other side of the parabola is easier now that we've used symmetry. So I notice that this point 0 is 3 steps to the right of my axis of symmetry. So if I go another 3 steps to the left, I should also have a y-coordinate of 5 there. Then if I go 1 more to the left, that's the point that's opposite this 1, 7 and 1/3. So it's going to be -7, 7 and 1/3. And the rest of my parabola looks like that.